Notes. Create. It's called Inscribed Angles. So what exactly is an inscribed angle? An inscribed angle is an angle, kind of obvious, that has its vertex on, what's important, on the circle inside the circle. So last week we learned that if we have a circle and there's its center, if we have an angle whose vertex, that's the pointy part, is sitting at the center, called a central angle, and it is equal to its matching arc. Okay, so we know that this arc and this angle are equal. That's what we did last week. This time, we're looking at an angle that goes all the way across the center, the circle, not the center, the circle. So this would be my angle, just some random angle. And this over here is its matching arc. So let's write that in. This is what we call intercepted or matching arc. And this is the angle, inscribed angle. Okay, so put in the chat box, here's an easy one for participation. Looking at this circle, which one appears to be bigger, the angle or the arc? Which one is bigger, the angle or the arc? Put it in the chat box. The angle or the arc? And I haven't taught on this yet, so it's pretty much just kind of whatever you think. But remember, they're not equal because the only one that's equal is if the vertex is at the center. So one of them is actually bigger and one of them is actually smaller. So I'm asking, which one do you think would be bigger? Okay, and most of you got it right, okay? Any other last minute participation, arc or angle? Okay. It's actually the arc that is bigger, okay? We actually have a double half relationship, which means that the arc is equal to 2 times the angle. Okay, the arc is actually 2 times the angle. So it's not like some random number. It's twice as big. So the arc is bigger than the angle. Arc is bigger than the angle. This is the relationship right there. So let's look at a couple small examples. Couple small examples. So you write that down. And you can put the answer in the chat box. Get it going there. Okay. So if that angle is 30, what would its matching or intercepted arc be? Go ahead and put your answer in the chat box. These are some really easy participation type questions, guys. Make sure you're tracking with me. It's a short day or short class period. Okay, so far everybody's got it correct in the chat box. Good. Nice. A few more, guys. What do you think? And the question is, how big is the matching arc for that angle? Nice. Good. Okay, so if we have a formula that says the arc is 2 times the angle, well, the angle is the one on the inside, so the arc is 2 times 30 or 60. You're done. Okay, and I don't need to see all of this. When I asked for work to be shown, I'm totally fine with 2 times 30 equals 60. Done. That's work. Okay. That's all I need. Right now, we're doing this so you can see the relationship. Okay. What about this one? So now we're going to try to find the angle. If I give you the arc is 100. Remember, the arc is bigger. Go ahead and put your answer in the chat box.
Wait, say that again, Ms. Richardson.
So I gave you the arc. This time we want to find the angle. So I'm looking for you to put the answer for the angle in the chat box. But remember, they're only going to be equal if it was at the center. When the angle goes all the way across to touch across the circle, it's not going to be equal. It has the same relationship right here. Okay, good. Many of you got it correct. That's awesome. Okay, so just remember, it's not equal. So the relationship that we have is that the arc is equal to 2 times the angle. Well, the arc is 100. Remember, it's bigger. 2 times the angle, so we can divide both sides by 2, and we get 50 equals the angle. So if you didn't put 50, do you understand why? You can put that yes or no in the chat box. Remember, the angle is always smaller than its arc. And again, if you're trying to show work on the homework, I'm totally fine with 100 divided by 2 equals 50. You're done. To me, that's showing work. Tells me that you understood the relationship and you're good with that. Okay, so we're going to start doing some from the homework assignment. Number 1, I'm not going to go in order, but very similar to what the examples we were just doing. Okay. So this one, they actually tell us that this line is a diameter. We know that because it goes through the center and it goes all the way across side to side. This arc is 64, and we want to find this angle. So put your answer in the chat box. Put your answer in the chat box. Remember, the arc is always bigger. You're close, Hayden. Good. So far, so good. Nice. Good. Okay. Delia, go back and look at your problem again and see how you might solve that. Yes, that's it. Yep. Nice. Okay. So again, and I'm not going to write this for every single problem, but I'm writing it so that you can keep seeing the relationship. So the arc is equal to 2 times the angle. The arc is 64. 2 times the angle. We divide by 2. 32 equals the angle. And you're done. Okay. So if you have questions, please stop me. Number 2. This one's a little more tricky because they give you an extra line. Okay. If it were only this, I think most of you could do it with no problem. They want you to find the intercepted arc. Go ahead and put in the answer in the chat box. And if you ever wonder, like, how do you find the intercepted arc? You can literally get just 2 little pieces of paper and you can block off the angle like that, and it will give you the intercepted arc. It would be this right here. So that's its matching arc. Good. Nice. Everybody has it correct so far. I told you, I mean, that it's not supposed to be super hard. Okay. I totally believe that some teachers make it hard. They don't have to. All right. So this is a double relationship. This is 2 times 62 or 124. And you're done. Okay. That was it. But the problem, the question throws in this line going across. Makes it look like a snow cone. That has nothing to do with the angle and its matching arc. Okay. It's the same problem with or without, we call it a chord because it doesn't go through the center and it goes side to side from your circle. It's chord. That chord has nothing to do with your problem right now. It will in a few minutes, but not right now. Okay. So if you need to, cover up that line that's making it difficult for you to see. Okay. Okay. So number 7. And this integrates some of the things that we were learning last week. So this arc is 65. This arc is 95. But I want to find that angle. That angle. So think about it for a minute. Don't yell out your answer. Most of you don't anyway, but I need this arc in red before I can find that angle. Unmute yourself and tell us, how do you think we could find that arc based on what we know from last week? Any ideas?
Add up. Oh,
No, go ahead.
You can go. You can go.
you can just add up the 95 and 65, and then subtract that from the 360 since it's a whole circle. And
Perfect. Nicely said. Thank you both. Okay, so if I want to find this, I know that my whole circle is 360. I can take away whatever's left, okay, so or whatever I have, so minus what I have. But have is 95 plus 65 for 160. So what I have is 160, which makes that arc 200. Okay. See how what we learned last week was important for this week. And now we can find this angle, because as some of you put in the chat box already, we do 200 divided by 2, and there's our answer. Nice. Okay. But we had to find this arc before we could find that angle. So what might be challenging for some of my students here, okay, and I get it, because when we start throwing in a lot of options, it's kind of like a restaurant that has too many choices. Okay, it's like you don't know where to start, you don't know what you want to eat. Here's some things to try. Okay, find all the arcs. If it's not a straight, obvious problem, start by finding all the arcs. Okay, so find all the arcs. If you need to, find all the angles. And that'll be more apparent later. Okay. Also, you may need to subtract something from 360 or 180. Remember, if you have a half circle, like on number 1, and you know that it's a half circle, then you might have to subtract something from 180. Here, we had to subtract from 360 because it was the whole circle. And then last, anybody remember what that little box means? How big?
90.
90 degrees. Okay. There's one of your problems that uses that in it. It's like, okay, I better remind them just in case. Okay, so these are some of the things that we'll want to try. This is not an exhaustive list by any means. This is just something to get you started. Okay. Is there anybody still writing? Okay. Let's do a couple more. Literally like just 2. Maybe 3. Okay, so let's look at number 8. Okay, so this first line that they give us does not go through the center, so it is not 180. We'll tell you that much. And then they give us this triangle over here. This is very much like the problem we just did. So this is 70, this is 94, and we want to find this angle. Oh, that wasn't what we were given. So sorry. Okay, so you may have found the angle already, but that's actually the information we were given. Okay. How would you have done it if you were only given that information? So the angle that we want to find has the intercepted or matching arc of that. So we need to find that first, which I just showed you what it was. Okay. So same idea. We know how much we have. We have 196 and 70. Kind of hard to know who's got it because I gave you most of the answer right there. Okay. So if you know what the angle is, go ahead and put it in the chat box. Good. I just might want to change your setting to just me instead of everyone. Okay, good. Nice. Okay. So if you didn't know the number I had put up there originally, we're adding these together again. So 196 and 70, and we get 266. So then we're going to take the 360 and subtract off what we have. So minus 266, and we would get 94. So that's how we get this number. Yes, you did, Elias. Okay. So far, everybody's got it. Okay, then we can use our half double relationship, and the angle is always half of the arc. So 94 divided by 2 is going to give us 47. Okay. So number six is pretty straightforward for what they ask for, but I'm going to use it as an example to show you different things. Okay. So let's do number 6, and then I'm going to expand it. So it does have a diameter. We know that it's a diameter because it goes through the center. And then it has a triangle. And they tell us that this angle is 38. And they want the arc over here. Okay, so this is actually a pretty easy problem because it's just here's my angle, there's my arc. Okay, good. Alex has got it. Alyssa, good. Leah, we want to look at the math on that a little bit more. Eric's got it. Dana, good. Let me wait for a couple more. Guys, this is participation. This one's the easy one. Let's try your multiplication again. Good, Josh got it. So it's not 60 and it's not 71. Okay, so let's look at, we know that this is the arc that goes with that angle. The arc is 2 times the angle. So 2 times 38 would equal 76. And you're done. That's number 6. I'm going to take it one step further, and you can do it on your paper, but I just didn't really want to confuse the two problems. Okay, so we know it goes through the center. Okay, this angle is 38. We know that this arc is 76. Find the other arc. Put it in the chat box. Find the other arc and put it in the chat box. Good, Alyssa's got it. This is what we were doing last week. Think about how big a half a circle is. Good. Nice. It's not 284. You subtracted from the wrong number. Try it again. Good. Because I need more than 5 people to participate here. This is where it gets critical. I need to know that you're tracking with me. And if you don't know, please put IDK. Alyssa's got it. All right, Alex, Dana. Thank you, Josh. Anybody else? Thank you, Elias. Okay, so how big is it from here to there? Anybody? Say it out loud. How big is it from that side to that side?
180.
180. So it's a half a circle. Well, I know I've got 76, so this is where I need to subtract from 180. So 180 minus the 76 gives me 104. That's it. So if this is 104, how big is this angle over there? Yes, Alyssa, you could do that too. Absolutely. Good. Good. So far, everybody's got it in the chat box. A few more, guys. We only have 4 minutes left. Okay. Remember our half double relationship? This arc is 104. That means this angle is half of that. Okay, so I would go 104 divided by 2 and get 52. Okay, so this angle is 52. And just really quick, how big is this arc over here? Anybody?
108.
180.
Oh, sorry.
180. And then, so what would that make this angle in here? Remember, that's my matching arc. That's my matching arc. Okay, so if this is 180, what's half of 180?
90.
90. Okay, good. So this is, again, is that half double relationship. So that means this arc is going to be 90 and you're done. Okay. But I wanted to use this problem to show you that even though this is all they asked for, there was a lot more they could have asked for. Okay. So when you're looking at your assignment, you actually have enough knowledge to complete the assignment, although we're going to go over some of it tomorrow. There are some more notes that I need to give you so you can do the second assignment for the week. So we'll go over at least half of this tomorrow, take some notes, and then we'll finish up going over the other 2 assignments on Wednesday. Any questions that I can help you with? Okay. If you do have questions, hang back as everybody leaves, and I would just say have a great afternoon, and we'll see you all tomorrow.
Have a good day.
Thank you. You too, Alex.
Thank you, Ms. Richardson.
You're welcome, hon.